Nonlinear systems are when we have two or more equations graphed on the same coordinate plane. The solutions of nonlinear systems are the ordered pairs, the points, where those two things, whether they are parabolas or lines or whatever they are, wherever those things meet. So it is possible to have no solutions, as is the case here and here. Or next to that, one solution if they meet at exactly 1 point, or two solutions if they meet or cross at 2 points. Now, graphically, if I give you a graph of two things and say, what is the solution to this system, you can find the coordinates of the points where they meet. So graphically, you just look at it, figure out where they meet, good to go. Algebraically, we are going to solve the systems using substitution and then using elimination. Take a look at number 1. What you might notice is that they are both y equals. If you remember geometry, this is called the transitive property. Do you guys remember the transitive property? Or have you completely blocked geometry from your mind? It's gone. So y equals thing 1 and y equals thing 2. So because y equals both thing 1 and thing 2, thing 1 and thing 2 are going to be equal. So the process for substitution is step number 1. We are going to substitute. Because y equals both of them, they equal each other. So negative x squared plus 5x plus 6 equals x plus 6. Step 2 is to get one side equal to 0. And it's important for the next step that your x squared be positive. So on the left side, we have negative x squared. That means instead of subtracting x and subtracting 6 and getting 0 on the right side, instead, I am going to add x squared to both sides, subtract 5x from both sides, and subtract 6 from both sides. Because that will take everything away from the left side and give me 0 equals positive x squared minus 4x, and 6 and negative 6 would be 0. Step 3 is to factor. If we have x squared and x, we get 0 on one side and we factor and solve. This is actually an easy factoring problem because there aren't 3 terms. If there's only 2 terms, think about what do these 2 terms have in common. How about just x? So we can pull x out of both of those. We can divide both of them by x. X squared divided by x is x. Negative 4x divided by x is negative 4. And that one is factored. Step 4 is to solve. Okay, so 0 equals x times x minus 4. The only way to get 0 is if x equals 0 or if x minus 4 equals 0. If x equals 0, then x equals 0. I know, right? If x minus 4 has to equal 0, what would x be to make that set of parentheses equal 0? Positive 4. So our two x values are 0 and 4. Now, normally we would be done, but this is a system of equations. That means these solutions are the ordered pairs where these two things would meet on the graph. So, our last step is to get the ordered pairs. These two things are going to meet at 0, something, and 4, something. The x values are going to be 0 and 4. We need to find the corresponding y values by plugging the x values in. So, which equation looks easier to deal with? The bottom one, y equals x plus 6. So, you could use either one. I'm going to use y equals x plus 6 because that one looks like the easier equation to use. So, plug in 0. 0 plus 6 is 6. 4 plus 6 is 10. So, our solutions, the points where these two things meet on the coordinate plane are 0, 6, and 4, 10. Step 1, substitute. Put the two things equal to each other. So we have negative x squared minus x plus 6 equals x plus 3. Step 2 was to get one side to equal 0, and we need our x squared to be positive. So I'm going to add x squared on both sides, add x, and subtract 6. We're looking for two numbers that multiply to give us negative 3 and add up to positive 2. That would be negative 1 and positive 3. So our factored form is x minus 1 times x plus 3. X would have to be 1, and our other x value would have to be negative 3. That's when you take the opposite of those numbers in the solving process. This means we have ordered pairs at 1 comma something and negative 3 comma something, and that's where these two equations are going to meet on the graph. So pick the easier equation, y equals x plus 3. And 1 plus 3 is 4. Negative 3 plus 3 is 0. So our two solutions are 1, 4, and negative 3, 0. The goal of the elimination method is to eliminate one of the variables. If we have x squared and x, we can factor, we can get our x values. The y makes things tricky. So we need to eliminate the y's. That means we need to get one of these to be positive y and one of these to be negative y, so that when we add them together, the y's will eliminate. So step 1 is to set up and eliminate the y's. Sometimes it'll be set up perfectly to eliminate the y's. Sometimes you're going to have to do something to it. In our case, the second equation, we need to multiply by negative 1. It will help you if you line up the things that match. Once you have them set up for elimination, add straight down. We end up with x squared plus 6x, the y's eliminate, equals negative 5. Once you get to this point, it doesn't matter which method you're using. Your next steps are going to be get one side equal to 0, factor, solve, plug the x values in. So the process is still the same no matter which method you use. So our next step is get equals 0, and you want your x squared to be positive. So in this case, we are going to add 5 to both sides to get that equals 0 on one side. Then we need to factor. Two numbers that multiply to 5 and add up to 6. That would be 1 and 5. Oh my goodness. So our factored form is x plus 1, x plus 5 equals 0. The next step is to solve. If x plus 1 had to equal 0, our x value would be negative 1. If x plus 5 had to equal 0, our x value would be negative 5. Step number 5 is a little bit trickier when we use the elimination method. the points where these things meet are -1 something and -5 something. The problem is the equations that we're going to have to use to find it are a little bit more complex. So we are going to use 2x plus y equals 5. And we have to plug these numbers into that. So right here, 2 times -1 would be -2. -2 plus y equals 5. That means y would have to be 7. Add 2 on both sides, y equals 7. Plug -5 in. 2 times -5 is -10. Add 10 to both sides, y would equal 15. So our solutions are -1, 7, and -5, 15. On number 4, it's going to be in your best interest to line things up vertically. So when you multiply the bottom equation by -1, line up the -x squared underneath 2x squared, line up the -y underneath positive y, and line up the 2 underneath the -2. That way when you add things vertically, it all matches up and it'll be easier. Yep, it's supposed to be -2, which would make this -4. Get 0 on the side. You're looking for two numbers whose product is 4 and whose sum is also 4. That would be 2 and 2. So our factored form is x plus 2 times x plus 2 equals 0. The fact that they're the same doesn't really matter. It just means that when we solve, our only x value is -2. So these two things are only going to meet at one point, -2 comma something. And I'm going to go back to the original second equation. You can pick any of the equations to plug it into. X squared plus y equals 2. So -2 squared plus y equals 2. That'd be 4 plus y equals 2. So y equals -2. There's a lot of -2's in this problem, isn't there? These two equations, if we put them on the coordinate plane, they would meet in only one location at the ordered pair -2, -2.